Hello everyone, this is a complete setup for our one of the product solar technology trainer, which consists of two SPV stands. This is the stand 1 along with this PV panel, and this is another second stand along with this second panel, solar panel, and this is a complete one experimental setup, you can say, as a XPO-STT rack. Now we are discussing individual panel functions for this solar technology trainer. Here is the first panel is for DC Voltmeter and DC Ammeter panel. Here two digital meters we have provided. For upper meter is for ammeter and this is for voltmeter to measure the DC parameters, and another second panel is for MPPT charge controller. Here the function of MPPT charge controller you can study by connecting all the leads. This panel consists of here one controller, and this is a battery inside a battery, and this is the output. It means you can connect, this is a solar panel here, and at a time solar panel gives the voltage to battery as well as load side. It means you can connect this load side to inverter also. So this is the main function of this maximum power point tracking charge controller. MPPT means maximum power point tracking charge controller panel. Third panel is for similarly first panel, this is the third panel. This is also for measurement of DC voltage and DC ammeter current. This is upper meter is for ammeter and lower meter is for voltmeter. And this is a fourth panel is for DC application load. It means when you are connecting this inverter, not an inverter but actually PV output, that time you can connect this LED lamp as well as this DC fan as a load. This is a LED lamp inside. And for AC load, here is the lower panel is given here for lamp load panel. It means you can either you connect first lamp or a second lamp or both lamp or at a time 3 lamp also, so as per your load requirement. And this panel is for AC voltmeter and AC ammeter panel. It means after this inverter you can connect this panel to this multifunctional meter for measurement of voltage, current, frequency, all the parameters, AC parameters. That's why here this is the second panel for this inverter output, and this is a panel for inverter application. It means this is a pure inverter. Here this is the input. You can connect here 12 volt DC input side, and this is the output of this inverter. Here different topology is given here. Suppose you can on this inverter here overload protection, battery low indicator and inverter indicator also shown here. And similarly for MPPT also, here 3 types of indicators are given here. First is for charging on, another is charging disconnect, and battery low disconnect. It means automatically battery will be disconnect from the PV side, after PV side, by using this MPPT controller. And so now we can study the actually working of this PV stand. Here two types of number of stands, similar stands are given here. So in stand, PV stand, This is a complete one frame is given here. Rack, you can say rack for SPV stand 2 and stand 1 also. Yeah, this is stand 1. Here, this is the driving circuit for this lamp. This is a halogen lamp given here, and 1000 watt halogen lamp. You can connect. Yeah, this is a AC operated lamp. Here first panel is for instrumentation power supply come multi-channel DPM panel. It means here this part of this panel is for connecting the AC voltages which is going to AC controller panel. It means here first MCB connected to this L1 and N1. This is the outlet point of this first MCB. This L2 N2 is output part of this second MCB, and this is the third MCB. Now the output of this third MCB is connected to the input of AC controller. Here you can control the firing pulses of these thyristors. These are thyristor first and second, third. These are the two thyristors. By changing the gate pulses of this thyristor, you can control the intensity of this AC lamp which is connected to output of this AC controller. Here there is a variable potentiometer for intensity control. Suppose this is a switch on the power supply for AC controller, then you can change the intensity of this halogen lamp. Here this is a panel, SPV panel, the solar PV panel, photovoltaic panel, and these are the connecting terminals for this SPV, which is connected to this SPV outlet goes to the DC meter here. So along with this complete setup, we are giving one manual, systematic and neat manual. Manual consists of two parts. One is student workbook and another is instructor guide. So this is the content of experiment. This is the content of experiment list. First is the introduction of this solar technology trainer. Here second chapter is for understanding resources panel. It means in this chapter we have given all the introductory part of each panel. This is a complete one setup, the diagram of our solar technology trainer. This is the understanding resources panel. These are the different type of panels we are using here. So everything is given in this chapter. Third chapter is a working with solar cell experiment panel. Another fourth experiment working with spectral response and carrier lifetime measurement. Fifth is working with solar photovoltaic module. Sixth is working with DC application panel, working with MPPT charge control panel. Eighth experiment working with standalone inverter. Ninth is working with grid tied inverter. This is an optional experiment actually, and this is 10 also optional, working with electroscopy. Now we are studying this 8th experiment working with standalone inverter. So go to experiment number 8. Here this is a working with inverter panel. This is a unit objective of this experiment. This is a description fundamental. This is a discussion and fundamental, and description is given here. This is a block diagram for this complete setup. These are different number of different panels we are connected as per wiring sequence. Wiring sequence is given in next page. This is the complete table for wiring sequence. You just refer this wiring sequence as a wiring sequence for SPV stand number 1 and 2 like this. Serial number 1 EMT 812 goes to EMT 97. It means EMT 8 is a panel name and 12 is a tag number or BS5 number, and this is a EMT 9 also. Similarly, this is a panel name and 7 is a tag number. Similarly, you can connect all these wiring sequence. This is for SPV solar PV stand number 1 and 2 wiring connections, and this table is for sequence for main rack. Main rack means main trainer, and here in panel also these are the procedure. Follow this procedure. Follow this procedure 1 2 3 4 5, and after procedure this is the observation table is given here. You can take the readings as per observation table, and this is the conclusion. So now we are going to calculate the efficiency of standalone inverter here. So for that we are connecting, this is another experiment also here. So we are connecting this wiring sequence here. This is a workout power flow calculation. It means here conclusion is given here. You can calculate the efficiency of that particular inverter by changing the load. It means here we are using 10 watt, 20 watt and 30 watt load side, and this is a without load. It means inverter off and inverting or load off. It means first we are using load for 3 lamps. Here we are using 3 lamps for load. This is a 10 watt lamp, this is a 10 watt, this is a 10 watt. It means if you want to 20 watt, that time on these two lamps. This is the on off switch is given here, toggle switch is given here for switching purpose, on and off for that lamps. So first of all, we change this firing angle of thyristor, and halogen lamp drops the intensity of light on the SPV panel number 1. Similarly, this is the SPV standard panel number 2. Here also this is the second panel, and these two panels are connected in parallel. So that's why here 13.7 volt is coming. So you just set it to 13.1, or you can use direct full current also. This is the voltage from PV panel, and this is the current. 1 ampere current is coming from connecting parallel connections of this two SPV panel, and this goes to here MPPT charge controller, and output of this MPPT charge controller goes to here one DC ammeter and voltmeter here also, and which is connected to this battery. It means battery and load side of this MPPT goes to inverter of input. Here this is the inverter, and output of inverter is goes to here multifunctional meter, and output of multifunctional meter goes to AC load side. These are the 3 lamps. Now switch on. This is the inverter, and here inverter indicates the inverter on indication, and then switch on first load. This is a 10 watt lamp load. Here this is a inverter output 224 volt AC, and this is the frequency, and this is the, and you can observe voltage and current of this battery side, and this is the SPV side. So note down these readings here. SPV power here, it means using this left side EMT68, this is the left side EMT68, this is the right side EMT68. So this is the battery power, one is battery power, and this is the L side, and this is the R side. SPV power, this is the SPV power, and this is the battery power. Calculate the power by using this ammeter and voltmeter reading, current and voltage. So note down here SPV power, battery power, this is the inverter input here, this is the inverter input, and this is the inverter output. Here AC load power is, you can calculate the AC load power also here, and this is the load side. Conclusion from the above experiment observation, we studied power flow calculation of standalone PV system of AC load with battery and power loss due to charge controller. These are the first conclusion. This is the second from the above observation. We study how a solar PV standalone system works and how to determine the power flow in a solar PV system. And third conclusion is when a AC load is made off or inverter off position, the SPV power is flowing into battery and battery start charging. Same readings, it means for your reference, this table number 8.2 is given. A reading of this 8.2 table is given at the end of this experiment. 8.2, these are the IG means instructor guide. This is the 8.2. Here you can refer this field observation table for your cross checking of your readings. Thank you very much.